Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 7 video on the chapter of area of trapezium and polygon, where I will discuss about how to find area of regular polygons using few methods, and we'll solve two example problems. If you have not watched the previous parts on this chapter, that is part 1 to part 6 videos, then I highly suggest and request that you please watch those videos also to maintain the continuity of your study on the chapter of area of trapezium and polygon. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 7 video on the chapter of area of trapezium and polygon. Okay, so in this video we will discuss about how to find the area of regular polygons. I will discuss about two methods how we usually find the area of regular polygons. Now you know that the regular polygons is a n-sided polygon where all the sides are of equal length, and of course the all interior angles are equal and all exterior angles are equal. Now to find the area of regular polygons, we do not usually need the angles. We need the length of the sides or any diagonal. So from the length dimensions, we usually find the area of a regular polygons. So the method 1 is based on 3 parameters. First, we need the number of sides of the regular polygons. How many sides? Whether it's a regular pentagon, that is n is 5, regular hexagon n is 6. We need the number of sides. The second one is we need the length of each side, that is a, and small n is the number of sides. And the third parameter we need is the length of perpendicular from center of the polygon on any side. This perpendicular will be equal for all the sides. And the formula for area, then the area of the regular polygon having n sides, where small a is the length of each side and small h is the length of the perpendicular drawn from the center of the polygon on any side. The formula will be NA h by 2, NA h by 2. Now let's see how this formula is coming. The concept is very clear, is very simple. So in this example, I have taken a regular hexagon. So ABCDEF is the regular hexagon. So n is 6, and the length of each side is a. So AB is equal to BC is equal to CD is equal to DE is equal to EF is equal to FA is equal to small a. Now and O is the center of this regular hexagon. Now the concept is that from the center O, if I join all the vertices of the polygon, that is, let's say I am joining AO and then I am joining OB. If when I have joined the vertex A and B from the point O, the triangle AOB, triangle AOB is formed. And if I now draw a perpendicular from the center O on the side AB, let's say this is the perpendicular, let's say this be T. So OT will be perpendicular to, OT is perpendicular to AB. So this will imply that OT is height or altitude of triangle AOB with AB as base, with base AB, which is equal to small a, that is the length of each side of the regular polygon. Okay, so this will imply what is the area of this triangle AOB. I mean short writing AR for area. So area of triangle AOB will be equal to half into base into altitude. So we will have half into the altitude OT. This will be h. This is small h. Since it is the perpendicular length of the it is the perpendicular from the center of the polygon O on the side AB, which will also be, as you can see, the height of the triangle AOB. So we have height half into altitude, that is height, and AB, that is the base, which is small a. So this is the area HA by 2 is the area of the triangle AOB. Now notice that we can create this triangle AOB. We can create such 6 such triangles if we join the center O with the other vertices. So I have joined OC, I have joined OD. Sorry, please note that my diagram will not be perfect. Please try to understand. I have joined OE, and if I join, let me first move the center somewhere else. If I join OF, sorry, OF. So you see there are six congruent triangles are formed. So this is the first triangle, this is the second triangle, third, fourth, fifth, sixth. So these are congruent triangles, and their area will be equal. And we can clearly see that the area of the total hexagon, the total area of the hexagon is the sum of the area of these 6 triangles. Okay. So this implies we can say that area of the hexagon A, B, C, D, E, F will be equal to how many triangles are there? There are n number of triangles. Since there are 6 triangles. Since it's a hexagon, in this example, it's a regular hexagon. There are n is 6. So for a regular polygon of n, if you connect the center of the polygon with all the vertices, there will be n triangles formed. So for this regular hexagon, the total area will be 6 times the area of each such triangle, which is HA by 2. So this is 3HA. Now 3HA is the formula for hexagon. If it was a regular polygon n, it would have been half into n into HA. So that is why this is how the formula, this formula is coming. H by 2 is the area of each triangle that is formed with the base with one side and the center. And since there are n triangles, n such triangles in a regular polygon of n sides, the total area of the polygon will be n into AH by 2, which is NAH by 2. So in this way you can find the area of a regular polygon if you know the length of the side length of each side of the polygon, and also the length of the perpendicular drawn from the center of the polygon to one side. So this was method 1. Method 2 is most widely used, and the most problems that you will solve will probably be based on method 2. In this method, there is no formula. In this method, we just depending on the number of sides and depending on what dimensions. So you will be given a regular polygon of some number of sides. Let's say it will definitely be starting from 5, that is pentagon or hexagon or heptagon or octagon, whatever. Based on the sides and the given dimensions, you have to divide the polygons into triangles, rectangles, trapezium or parallelograms, whose area you can easily find based on the given dimension. And then you just basically add the area of these individual triangles, rectangles, trapezium and parallelograms, which will give the area of the whole regular polygon. So this is the basic idea. So let's take two example. For example, in the figure example 1, we have a regular. How many sides are there? 1, 2, 3, 4, 5, 6. So this is a regular hexagon. And let's say you are given this hexagon A, B, C, D, E, F, and you are given the dimensions. That is, it is given BE is equal to Y. It is given each side, that is CD. CD is a side, is a small a, and you are given if basically what is x? X is nothing but if you x is nothing but FD. If you join FD, or if you join the diagonals AC or FD, x is AC will be equal to FD. This is given as x. Now, since this is a regular hexagon, please note that AC and BE will intersect at right angles. This will be right angle. Also, this will be right angle. So, in this particular figure, that is it's a regular hexagon. We will have so we will have let's say AC is intersecting the diagonal AC is intersecting the diagonal BE at, let's say, O, and also let's say O. Now it will be a fact that AC will be bisected by AC is bisected by BE. It will be bisected by BE. This will imply that AO will be equal to OC. So this will imply that OC will be half of AO plus OC, which is equal to half of what is AO plus OC, that is AC, which is equal to x by 2. Okay, so OC is x by 2. Now, how do we find the area of the hexagon? Please note that the diagonal BE bisects the hexagon ABCDEF into two congruent trapeziums, which are BCDE and ABFE. I'm running out of space. Okay, let me make some space. So this is equal to half of AC. This is equal to x by 2. Let me move this. Okay, so we have so we can see that the entire hexagon ABCDEF has been divided into two congruent trapeziums. The first trapezium is on the right hand side of the diagonal BE, which is BCDE, and the other congruent trapezium is on the left hand side of the diagonal BE, which is BAFE, and they are congruent, and so their area will be equal. Now, how to what is the area of trapezium? Area of trapezium BCDE is equal to half into the sum of the parallel sides, that is CD plus BE into its altitude. The altitude will be OC. So this is equal to half multiplied by What is CD? CD is small a, that is the length of each side of the regular hexagon. What is BE? BE is given to be y, and we have OC. OC is x by 2. So this will be the formula, that is x into a plus y divided by 4, based on this given dimension for the regular hexagon ABCDF. Now please note that this x into a plus y by 4 is not any formula. I am not trying to give any formula. I am just trying to explain, if these are the dimensions given, then this way we can find the area of the entire hexagon, that is the diagonal BE. We can see that diagonal BE is dividing the entire polygon, regular polygon, that is regular hexagon, into two congruent trapeziums, and whose area individually we can easily find from the given dimension. Okay, now let's see the same regular hexagon. If different dimensions are given, how do we find the area of the polygon? So in this same regular hexagon, the side is given as A, but as you can see, AO is given. Now obviously BE and AC will intersect at right angles, so we are given small x, which is AO. Now and also y is given. Now in this diagram we will have one second. Okay, so we are given AO is x. AO is x. So we will have OC will be equal to also x. OC will be also equal to x, and in the same way as we did in the example 1, the area will be same, but since this time OC will be equal to x, in the previous example 1 OC was coming out to be x by 2 based on the given dimension. So in this case the area of ABCD EF will be equal to two times, since there are two trapeziums, 2 times the area of each trapezium, which is half multiplied by the sum of the parallel sides, which is a plus y, and multiplied by the height, which is x. OC is the height of each trapezium. So we have this. So this is coming out to be x into a plus y. Oh, sorry, in the previous example, x into ay plus y by 4 is the area of one trapezium. So the area of the entire polygon ABCDEF will be 2 times x into a plus y by 4, which is x into a plus y by 2. And in the second example, since AO is given to be x, it is coming as x into a plus y. I'm just trying to explain based on given dimensions how we can find the area of a regular polygon. In the I have taken the example of regular hexagon. It could be any other regular polygon, like it could be a heptagon, octagon. Now if the number of sides is more, then obviously you will create more triangles or more rectangles or even more trapeziums. So let's see another example. In this example, the number of, this is a, how many sides are there? 1 2 3 4 5 6 7 8. So this is a octagon. This is a regular octagon, that is n is equal to 8. Number of sides are 8. Now you see what dimensions are given? It is given that the length of the diagonal AC is equal to y. Each side is given to be A. So CD, which is the length of each side, is A, and we are given that there is a perpendicular drawn from the vertex A on HC. Let the perpendicular be T, AT. So we are given AT is perpendicular to HC, and AT, the length of AT is equal to X. So from this fact, how do we find the area of this regular octagon? Now clearly you can see that the diagonals AC and GD is dividing the entire regular octagon into two trapezium and one rectangle. So okay, so we can say that area of the entire regular octagon, that is A, B, C, D, E, F, G, H, area will be the area of the trapezium A, B, C, H, plus in the middle you can see we have a rectangle, area of rectangle HC, D, G, and at the bottom we again have another trapezium which is GD, E, F. Now since these are all regular polygons, the figures will be very symmetric. By that I mean both this trapezium, the trapezium above the rectangle and the trapezium below the rectangle, they are congruent, so their area will be equal. So we just need to find the area of one such trapezium. Okay, so what will be the area? So this will be equal to we can say that area of rectangle HC DG plus 2 into area of the one trapezium. Let's say trapezium ABCH. This is equal to, what is the area of the rectangle HCDG? We know it is the product of length and breadth. The length is HC, which is y into the height, the breadth of the rectangle HCDG is CD, which is the length of each side of the regular octagon, which is small a, plus 2 into what is the area of the trapezium above the rectangle. So it will be half multiplied by the sum of the parallel sides. So we can clearly see these two are the parallel sides, and the height of the trapezium ABCH is 80. So we can have the sum of the parallel sides will be A plus y, and the height is given as x. That is 80 is given as x, which is the height of the trapezium. So this becomes y plus a multiplied by 2 gets cancelled out, which is x into a plus y. If I take a plus y common, I get a plus y multiplied by x plus this will be not multiplication but plus x plus 1. Kind of a nice formula, but please do not try to consider this a plus y into x plus 1 as a formula. I am not trying to give any formula. I am just trying to explain based on given dimensions how we can divide the regular polygon into some trapezium, rectangles or triangles or even parallelograms, and find the individual area of those triangles and parallelograms, rectangles, and add them up. This is the primary objective of discussing with these examples. Okay, so this was all about how we find the area of regular polygons. Now let's try to solve two problems. So the first problem says that ABCDEF ABCDEF is a regular hexagon. So we are having 6 sides. Okay. Diagonal AD intersects diagonal EC at the point O. At the point O, AB is equal to A, small a, that is the AB is the side of the regular hexagon, is A, and EC is equal to M. Okay. If area of the hexagon is capital A and the ratio A is to M is 1 is to P, then M will be equal to, okay, it is asking the value of M in terms of A and P, capital A and P. Okay. What is given? The side length is given, and EC is given. EC is given. Now, from the given dimensions and the figure, you must be able to easily observe that which line segments are perpendicular to each to which line segments. For example, in this figure, I should be very clear that EC and AD, the diagonal EC and AD are intersecting at right angles. And also I can see that all these lines FE and AD and BC, they are parallel. They are parallel to each other. Okay, and now I can clearly see that the diagonal AD is bisecting the entire regular hexagon into two trapezium. That is, on the right hand side we have ABCD, and on the left hand side we have AFED. We already know that this will also be small a. Now, how do we know? Okay. How do we know AD? AD is will be one parallel side of the two trapeziums. How do we know AD? Now, if I join also FB, also, this will also be perpendicular. Now, and also I can say that EC, the diagonal EC is bisected. EC is bisected at O by AD. So this will imply that EO will be equal to OC. This will be equal to half of EO plus OC. Now, what is EO plus OC? It is EC. Now, EC is given to be M. So this is M by 2. So EO and OC, they are equal, and they are equal to M by 2. Now, what is OC? OC is definitely, OC is height of trapezium ABCD. Now, to find the area of the trapezium ABCD, we need to know its parallel sides, length of its parallel sides. One parallel side is BC and the other parallel side is the diagonal AD. We know BC because BC is equal to A. How do we find AD? If the area of the hexagon is A, the area of the entire hexagon is given as A. Okay. Now, let's say if FB and AD intersects at the point, let's say T. Now OT will be equal to, definitely OT will be equal to BC, will be equal to A. That is FBCE will be definitely will be a rectangle. So OT is equal to BC is equal to A. How do we find AD? We need the length of AT and OD. And AT and OD, AT will be equal to OD. AT will be equal to OD. How do we find? OT will be A. OT will be A. Somehow we have to find OD. Now in triangle, since in triangle, consider the right angle triangle ODC. In the right angle triangle ODC, this is A, DC is small a, and OC is equal to M by 2. OC is equal to M by 2. Okay. And since it's a right angle triangle, we will have DC square is equal to OC square plus OD square. M. Oh, I think I'm thinking in a wrong direction. I think I have to now. Please also consider. Please no. I was thinking of finding the area using the diagonal AD, which is bisecting the hexagon into two trapezium. But for that, I need the length of AD, which I do not have. I mean, I can using Pythagoras theorem. I can find DC square. I can find DC square. Let's say this will be DC is A, so we will have A square is equal to OC square. OC is M by 2, so M by 2 square plus OD square. From here I can easily find OD in terms of A and M, but that will be a little complicated. I think there is a better way of solving this problem, is that using the formula from that is using the method 1, which is using the side length, the length of perpendicular from the center of the polygon on a side and the number of sides. We know this is a regular hexagon, n will be 6, and side length we know it is A, and this M from M we got, so let's we don't need this. This is the wrong way. I mean, possibly we could also solve using that method, but I think the better way is, please observe that the center of this regular hexagon will be the midpoint of will lie on the diagonal AD, and it will be the midpoint of the diagonal AD. Let's say this is the center P midpoint of AD is the, now all these observations you have to make based on the fact that it is a regular hexagon having 6. It is a regular hexagon, so it has 6 sides, and since, so if I so from the center P, now from the center P, if I draw a perpendicular to the side BC, let's say this is, I'm really sorry for my clumsy illustration, but let's say this is Q. PQ is perpendicular to the side BC, and this, what is PQ? PQ is the perpendicular from the center of the polygon, the center of this hexagon, which will be the midpoint of the diagonal AD on the side BC. Now PQ, we already know it will be equal to OC. So P, midpoint of AD, is the center of the hexagon, or the center of the regular hexagon, and PQ is perpendicular to BC, will imply that PQ will be equal to OC, which is equal to m by 2. So we got the length of the perpendicular from the center of the polygon to one side, which is BC, which will be equal to m by 2. Since it is given EC is equal to m, and definitely half of EC will be the length of the perpendicular from the center to one side. Okay. So now we can say that area of the regular hexagon ABCDEF will be equal to, we know the formula is n, that is the number of sides, which will be 6, h, which is the height of the perpendicular from the center of the polygon to one side, which in this problem is m by 2, and a is the length of each side of the polygon, which is small a. So this is equal to 3 ma. So the area of the entire regular hexagon will be 3 ma, which is given as capital A, Okay. So this implies that capital A is equal to 3 ma. We need to find the value of m. Okay. In terms of A and P. So we are having, from this equation we can find m in terms of A and capital A and small a, but we have to find small m in terms of capital A and small p, as all the given choices are in terms of capital A and small p. So we now need to use the ratio. The ratio of A is to m is given as 1 is to p. So it is given that A is to m is equal to 1 is to p. This implies that A by m is equal to 1 by p. This implies that A is equal to this implies m is equal to AP. M is equal to AP. Now, using the fact that capital A is equal to 3 ma, we can say that A will be equal to 3. What is m? M is equal to AP. So AP into A. This is 3 A square P. So from here we can say A square is equal to A square is equal to the formula of the area was NaH by 2. Okay. So n in this problem is 6. So 6 H is OC, which is m by 2, and the side length A. Okay, so this is 3 ma. Okay. M by 2. The formula of the area was NAH by 2. NAH by 2. Okay, so I think I did one small mistake. So this will be N is 6, H is M by 2A, and this whole divided by 2. So this will be equal to 3 M A by 2. Okay, so this is by 2. Okay, so now we have this by 2. So this by 2. So this implies that A square is equal to, we can say, from A is equal to 3A square P by 2, we can say that A square is equal to 2A by 3P. So this will imply A will be equal to square root of twice of A by 3P. So we have found small a in terms of A, capital A and P. Now we know that M, small m, is equal to AP. This implies small m we know is equal to AP. This now will be equal to A. Sorry, A we have found to be square root of twice A by 3P, and this multiplied by P. If we take the P inside the square root, it will become P square. So this is equal to twice of A P square divided by 3P. So this becomes, after simplification, twice A P by 3. Square root of twice AP by 3 should be the value of M. So the correct answer is choice C. So this problem was based on applying the formula of the area of a regular polygon based on the side length, the length of the perpendicular from center of the polygon to one side, and of course the number of sides. Now in this problem I could have found the area by using the two trapezium on either side of the diagonal AD, but for that I would need the length of the diagonal AD. Now the length of the diagonal AD could be found by using Pythagoras theorem if we know that AT is equal to OD, and the diagonal AD will be equal to twice of AT plus TO, OT, and OT is the length of the side A, and OD we can find OD using Pythagoras theorem from M and A, but that would be the results would be a little complicated using square roots. I hope this is a better way of solving the problem. Okay, let's see the next problem. Okay, so we are given ABCDEFGH is a regular octagon. So we are having 8 sides, and AI is perpendicular to HC, the diagonal HC. FJ is perpendicular to diagonal GD. If AB, that is the side of the side AB is equal to 5x, which means that length of each side of the regular octagon is 5x, and AI which is perpendicular to HC is 4x. That is, AI is equal to FJ is equal to 4x, and area of the hexagon A is equal to kx square. Then value of k is k must be some constant. If it is saying that if the area of the entire hexagon, it will not be hexagon, but this is wrong. This will be octagon. If the area of the octagon is A is equal to kx square, then what will be the value of k? Okay, so the idea is that we have to find the area of the octagon, and it will be definitely in terms of x square, and comparing that area, our area, with kx square, we have to find the value of K. Now, how do we find the area given on based on given dimension? Okay. 4x. So we know, so we can clearly see that the diagonal HC and GD are dividing the entire octagon into two trapezium. In the middle we have the rectangle HCDJ, and above the rectangle HCDJ we have a trapezium ABCH, and below the rectangle we have the trapezium GHEF. Now, since it's a regular polygon, you have to be very you have to immediately observe that what triangles, what trapeziums, and what rectangles are being formed based on the given figure and based on the given figure. Now, since AI is perpendicular to AC, HC, so AI will be the altitude of the or height of the trapezium. Since AI is equal to FJ, we can also see that HC DJ will be a rectangle. Now, this CD, that is the breadth of the rectangle, we know it will be 5x, since it is a side of the regular octagon, 5x. We have to find HC, that is the length of the rectangle. We have to find which is HC or GD, and we need to find, if we can find that, we can also find the area of each trapezium. So the first task is to find HC or GD. HC is equal to GD. How do we find? Now, if I drop a perpendicular from B on HC, let's say this be O, then from the, since it's a regular octagon, from the similarity of its geometry, I should be able to clearly observe that HI, so let's say if BO is perpendicular to HC, will imply that HI will be equal to OC, We don't know what will be its length, but if once HI and OC are found, we can easily find HC, because HC will be equal to HI plus IO plus OC. HI we don't know, we have to find HI. So this will be equal to HI. Now what is IO? IO is equal to AB. So this will be 5x, and OC is also equal to HI. So this is HI. So this will be 5x plus twice of HI. This will be HC, which is one parallel side or the larger parallel side of the trapezium, of both the trapezium and also the length of the rectangle. How do we find now HI? If we can find HI, we will be able to find HC. Now consider in triangle, right angle triangle AHI. From the Pythagoras theorem, we can say, so this AH, we can say that AH square will be equal to AI square plus HI square. I am considering the Pythagoras theorem in triangle AHI because I know what is the one arm, that is length of one arm, that is AI 4x, and I also know the hypotenuse AH, which is the length of each side of the polygon. So I can easily, using Pythagoras theorem, I can find HI. So this implies, what is AH? AH is each side of the polygon, which is 5x. So we have 5x square is equal to what is AI? AI is given as 4x square, and we have HI square. Solving this for HI, we will get HI square is equal to 25x square minus 16x square, which is 9x square. So this implies HI will be equal to square root of 9x square, which is 3x. So this will imply that HC will be equal to 5x plus 2 into 3x. HC was 5x plus 2 into HI, and HI is 3x. So HC is 11x. So we know HC is 11x. That is the length of the rectangle HC DG. Okay. So now we can easily find the entire area of the octagon. So area of A, B, C, D, E, F, G, H will be the area of the entire octagon. The regular octagon will be twice, since both the trapezium above the rectangle and below the rectangle, they are congruent, so their area will be same. So twice the area of trapezium. The above trapezium is ABCH. ABCH plus we have the area of the rectangle. Rectangle is HCDG. HCDG. This is equal to twice of what is the area of that each trapezium. One parallel, the smaller parallel side is of length 5x. The larger parallel side is of length 11x, and the height is 4x. So half into 5x, that is sum of the parallel sides, into height is 4x. And what is the area of the rectangle? The length is 11x, and the height is the breadth is each side of the polygon, that is 5x. If I simplify this, we have 2 into half into 16x multiplied by 4x plus 55x x square. So this is equal to, after further simplification, 2 gets cancels out, we get 64x square plus 55x square. This is equal to 119x square. Now, so this implies so this is the area 119x square is the area of the entire regular octagon, which is given to be kx square. So we can say that now 119x square is equal to kx square. This will clearly imply that k is equal to 119. So the correct choice is D. D is the correct choice. So this was 2 example problems just to give you a feel how we find the area of regular polygons. So one method is that if you are given the length of each side of the polygon and the length of the perpendicular drawn from the center to one side to any side, the formula will be NaH by 2, where n is the number of side of the polygon, regular polygon, a is the length of each side, and h is the perpendicular length of the perpendicular from the center of the polygon to one side. And the method 2 was to consider dividing the polygon into triangles, rectangles, trapeziums, squares, or even parallelograms, and then add those their areas to find the entire area. The method 2 will be highly dependent on the given diagram and the dimensions. So that is all for finding the area of regular polygons. I hope this video was beneficial. If it is so, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So theoretically, I have completed all the concepts of finding area of a trapezium and polygons. In the next video, I will solve the problems of exercise 18B and 18C from the textbook of author RS Aggarwal. So once these are complete, then possibly I will prepare 2 assignments based on the entire concept, based on the concepts of the entire chapter, that is area of trapezium, polygons, and also area of quadrilaterals. And also after this is complete, I will parallelly prepare and solve 5 good problems, relatively harder problems in the other playlist, that is Maths 8 Hot. So all these videos are coming soon. So please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.